So this is the second part of chapter 7.1. We have two objectives here. We're going to find areas under the standard normal curve using the TI 83 and 84. And then we're going to find z-scores corresponding to areas under the normal curve. We're going to use the table first, and then we're going to use the TI 83 and 84. So we're going to find areas under the standard normal curve using the TI 83 or 84. So you will recall in the first part of section 7.1, a normal distribution can have a mean and any positive standard deviation. However, the normal distribution with a mean of 0 and a standard deviation of 1 is known as the standard normal distribution. And our x-axis is going to be called the z under the standard normal. And the z is the z-score, which tells us how many standard deviations a particular value of z is away from mu at 0. So you will recall also in the last section we said to find the z-score in any z-score value that we're going to ultimately find, it's going to be x minus mu divided by sigma, and we'll see that in the next chapter. But this value of z on the x-axis under the standard normal is called the z-score value. And you will recall that again the mean has a z-score of 0 right at the center. That's the mean, right? So the mean is 0 standard deviations away from itself, right? And the mean is same at the median. The points on the horizontal axis to the left of the mean have negative z-scores, and any point on the right-hand side has a positive z-score value. So in using the TI 83 or 84, we're going to use the command normal CDF. And we find it by typing in or pressing on the TI 83 or 84 the two keys second vars. When we do that, we get this particular menu screen, and we choose option 2. When we choose option 2, we're going to input the lower bound, which is the lower bound of the area. The second entry, we'll put a comma in, and we'll put an upper bound of the area. And then the last two entries, we'll put in the mean and the standard deviation. So here's our first example. You will notice that this is very similar under the part 1 where we were looking under the table, but now we're using the TI 83 or 84. It says find the area to the left of z. So in this particular case, I'm going to call it the probability of z less than 1.26. So that's what we're doing. We're finding the area, which is a probability. And how we're going to do that is we are going to use the second vars command, and then we're going to select the normal CDF. The lower bound in this point is going to be a negative E99. Well, if we don't have a bound on the left side, it's always going to be considered 1E99. Okay? And then the upper bound, as you can see, is going to be 1.26. And in this case, since we're doing the standard normal curve, we know the mean is 0 and the standard deviation is 1. Notice the commas in between. When we hit enter, we get the probability of 0.896. Now we're going to look at finding the area to the right of z. Here in this particular case, we have the probability of z greater than a negative 0.58. And now, so this is going to be our lower bound under the normal CDF. So our lower bound under the normal CDF command is going to be negative 0.58. The upper bound is going to be 1E99. Why? Because there is no upper point that we can pick out. So the calculator wants the farthest it can go, which in this case is 1E99. And again, since it's the standard normal curve, we're going to put 0 as the mean value and 1 as the standard deviation. When we hit enter, we get our result of probability of 0.719. Now we're going to look at finding the area between z at negative 1.45 and z at is equal to 0.42. The way we represent that is the following. Negative 1.45 less than z less than 0.42. We select again the normal CDF command and we notice that the negative 1.45 as the lower endpoint and the upper endpoint is going to be at 0.42. Again, because it's the standard normal, the mean is 0 and the standard deviation is 1. We get the probability of 0.589. Objective 2, finding z-scores corresponding to areas under the normal curve. We're going to look at tables first. So we've been finding areas under the normal curve from given z-scores. Many problems require us to go in the reverse direction. That is, if we are given an area, we need to find the z-score that corresponds to that area under the standard normal curve. For example, we want to find the z-value when the area is 0.26. So that is, we want to find a value z that has an area of 0.26 to its left. So we sketch the normal curve and shade in the given area. We look through the table, the standard normal table, to find the area closest to 0.26. In this particular case, it is 0.2611. Now we go across and up at the top of the table, and we see that the z-score that corresponds to that area, or probability, is nothing more than negative 0.64. Again, we want to find an area of 0.68 to its right. So the only way we can do that is we sketch the normal curve and shade in the given area. So the z-score table itself only looks at area to the left of the value z. So what we have to do is we subtract 1 or 1 minus 0.68, and we get the area that is to the left of z, which is 0.32. Now we can find z by going inside the table and searching for the area closest to 0.32. In this case, it's 0.3192. And so our z value that corresponds to this value is negative 0.47. So if you recall, sometimes we want to find the z-score values for under the empirical rule, right, where the middle portion of the z-score is 95%. You'll notice in this case that because of the symmetry, that these two areas here on either side of 0.95 is going to also be symmetrical, and therefore those two areas added up has to equal 0.05. So to find z1 and z2, we go ahead and we sketch the normal curve and we shade in the given area. And since the area to the left of z1 is half of the area of both of the areas added together of 0.05, which is 0.025, now we take this number and we're going to go inside the table. So when we go inside the table, we find that the z value for 0.025 is equal to a negative 1.96. And because of the symmetry of the normal curve, the z2 value is going to be the positive 1.96. We'll now go to Objective 2, finding the z-score corresponding to areas under the normal curve or standard normal curve. We're going to use the calculator this time. So again, we're going to start with the same problem, right? We're going to try to find the z value under the standard normal curve for the area equal to 0.26. So the invert norm command in the TI 83 and 84 calculator returns the z-score value with a given area to its left. Notice it is to the left, and that's very important. This command takes three values as its input. The first value is the area to the left. The second and the third values are the mean and standard deviation. So to get our screen, we hit the second vars key, we get this screen, and we pick option 3. When we pick option 3, then we'll put in the values, the area or the probability, comma, the second value is going to be the mean value, comma, and then the standard deviation, parentheses closed. So to find the z-score that has an area of 0.26 to its left, right, so we're trying to find z in this case, and we know the area is 0.26. we select the inverse norm command using the second vars, and we enter in 0.26 as the probability, and then because it's the standard normal, the mean is 0 and the standard deviation is 1. The z-value we get back is a negative 6.6433. So now we want to find the area, or the probability, of finding the z-score for the probability where the area is equal to 0.68 to the right of z. So the solution is we're going to take 1, we're going to minus 0.68. Since the calculator and the tables are all the same, they work the same way, we're only going to get to the left of the area for the inverse norm. We hit the second vars key and we search for option 3 to get the inverse norm. And the first input is going to be 0.32, and the mean is 0 and the standard deviation is 1. We get the z-value of negative 4 or 0.468 about. And you should try this also on your calculator as well. Finally, to find the middle 95% of the area under the standard normal curve, again, we know that this area here is 0.025. We use the inverse norm. We plug it in to the first position. We put a comma. We put in the standard normal mean, which is 0, and the standard deviation, parentheses closed, and there is our z-value, which is negative 1.96 approximately, right? But that's rounded up to 2 decimal places. And by symmetry, the positive side is just going to be the positive part of the area. Or we could have put in this case, we could have put in 0.975, and we would have also gotten a positive 1.96. So that's the other way of doing that. So again, in this chapter, we know how to use the probability density curve to describe a population. We know the shape of a normal curve, and it's affected by the mean and standard deviation. And we found areas under in this case, a standard normal curve, and we found z-scores corresponding to areas under a standard normal curve. So both of these ideas, we just use the standard normal curve. In the future, we're going to use the normal curve to find our probabilities. This concludes chapter 7.1, and we will be reviewing next 7.2.